Problem 4. The function f of x equals square root of x has domain from 0 to infinity. Prove that f of x is continuous on the interval from 0 to infinity, not including 0. This function is also continuous at 0, but the proof is slightly different for that case. Let's begin with some scratch work. The statement we eventually want to end up with at the end of our proof is that the distance from f of x to f of c is less than epsilon. Now for our particular function f, what that says is that the distance from root x to root c is less than epsilon. Now what we're going to be allowed to assume in our proof is that the distance from x to c is less than some delta of our choosing. And so to make absolute value x minus c appear on the left side, what we're going to do here is multiply on the top and bottom by the conjugate, root x plus root c. And when we combine the numerator, we get what we want by difference of squares. Absolute value of x minus c over root x plus root c is less than epsilon. And then clearing the denominator, we get that the distance from x to c is less than epsilon times root x plus root c. Now the temptation at this point is to say, okay, there's my delta on the right-hand side. The problem is that delta is not allowed to depend on x. It's okay if it depends on c, but not on x. And so what we want to notice is that if we just drop that x term from the right-hand side, so that we have epsilon times square root of c, if this last inequality is true, then the one before it is as well, because this right-hand side is always greater than or equal to the one below. And so the last inequality implies the one above it. And since we're going to be following these inequalities backwards in our proof anyway, that's just fine for us. So we can choose epsilon root c to be the delta in our proof. So let's go ahead and try and write down a proof based on that scratch work. First we will let c be a number between 0 and infinity. And then as in all epsilon delta proofs, we will start out by saying given epsilon greater than 0, let delta equal, in our case, epsilon times square root of c. Then if the distance from x to c is less than that delta, and we also want to make sure that x is in the domain of our function, then just replacing absolute value x minus, replacing delta by what we've defined it to be, we get that absolute value x minus c is less than epsilon times root c. And as we noted in our scratch work, that itself is less than or equal to epsilon times root x plus root c. So looking from beginning to end there, and then dividing both sides by root x plus root c, we get that absolute value x minus c divided by root x plus root c is less than epsilon. And now we're just following our scratch work backwards. And separating that out, we get that absolute value of root x minus root c times root x plus root c over the same thing must be less than epsilon. And therefore, since that fraction is 1, we get what we want, namely that the distance between root x and root c is less than epsilon, which completes the proof.